The quest to explore into the depths of the universe began when the mighty man gazed into the sky jeweled with twinkling stars. It is in fact this quest that paved the way to an era of rockets, of spacecrafts, and of course of rocket propulsion. Through his mighty inventions, the mighty man has now set foot on the moon, and his mighty presence can be felt even at the brim of the solar system, where the Voyager spacecrafts are all set to explore into the unexplored, unimagined, vast infinity. It is at this juncture that we are trying to teach you how a small group of scientists under the able leadership of none other than Vikram Sarabhai could transform India into a global space power as you see right now. Welcome to this episode of the World Space Week lecture series. We are organizing now Rocketry in India. When you think of a rocket launch, the first thing that comes into your mind would be of scientists like me wearing white overalls, sitting inside a room, anxiously watching over a computer screen which is displaying some numbers, some plots, some graphs, and whatnot. And then you have the eventual legendary countdown which states mark minus 5, 4, 3, 2, 1, 0, and we have liftoff, and at that precise moment a rocket majestically lifting off into the pale blue sky, leaving out a trail of smoke behind it, and of course with that thunderous sound. In fact, if you look back in history, you would understand that rocketry did not have this pompous boom at its start. Rocketry in fact had a humble beginning way back in the ancient Chinese civilizations. The ancient Chinese folklore in fact talks about gunpowder being discovered and used as fireworks. Gunpowder is known to have been discovered in the 9th century AD during the Tang dynasty in China. Gunpowder was used for many applications, including fireworks and experimental medicine. Though the explosive power of gunpowder was known to the ancient Chinese, no references to using it in warfare as bombs or missiles is available. So, it is fair to assume that the same was used only for peaceful entertainment purposes. Ancient Chinese legends and folklore, however, tells the story of a wealthy landlord named Wan Hu who had this dream of going to the moon. As per the story, Wan Hu was so obsessed with his dream that he had his servants tie him up to a chair fitted with flying fireworks. The story ends by the servants set fire to all the 40 plus firecrackers attached to the chair and Wan Hu disappearing in a thick white cloud of smoke. Though the story may seem hilarious now, Wan Hu could be considered the first ever scientist who thought of using explosives for transportation. It is noteworthy that though Wan Hu would not have reached moon in the ancient times, his name did reach the moon when one of the lunar craters was named after him. The next mention of rocketry in history comes from India. Tipu Sultan using fireworks against the British Empire is that mention. In fact, some of these rockets, which were converted and used as missiles by Tipu Sultan, is still preserved at various museums across the globe for enthusiasts like me to ponder over. Tipu Sultan, the king of Mysore, is known to have used missiles developed from fireworks against the British Army. The Mysorian Rockets, as they are called, is the first recorded attempt to use rockets in warfare. Tipu Sultan and his father Hyder Ali had a fleet of rocket corps in the Mysore army. During the Second Anglo-Mysore War, Colonel William Bailey's ammunition stores are thought to have been detonated by a hit from one of Hyder Ali's rockets at the Battle of Polilur in 1780, which contributed to British defeat in the battle. Tipu Sultan deployed his rocket corps against the British East India Company during the Anglo-Mysore Wars. These missiles were fitted with swords and traveled hundreds of meters through the air before coming down with edges facing the enemy. The British took an interest in the technology and developed it further during the 19th century. The Mysore rockets of this period were much more advanced than what the British had previously seen, chiefly because of the use of iron tubes for holding the propellant, which enabled them to have higher thrust and much longer range for any missile of the time. The third reference to rocketry in history comes from here, Europe. The German forces under Adolf Hitler designed, developed and used something called as the V2 rockets as missiles against the Allied forces, especially the United Kingdom. Now these weapons, these novel weapons which would emanate from nowhere in the sky would come flying and would destroy cities and would cause mass destruction. Now these weapons were seen with fear by the Allied forces. These weapons were seen with so much fear that the Allied forces in fact wanted this technology, this novel technology of rocketry from Germany rather than the wealth of Germany once the Germans fell in the World War II. V2 rockets was developed by a team of German scientists including the very famous Werner von Braun, who later became the chief rocket engineer of NASA. A series of V2 attacks were made by the Germans against the United Kingdom, and this novel warfare was a nightmare for the Allied forces. After the fall of Germany in the Second World War, the US Army was the first to invade Germany. The invaders, who were in search of the new rocket technology, struck gold when they discovered the team of scientists who designed and developed the V2 rockets. This team was transported to the US and they were given US citizenship before enrolling them into the US Space Wing. The Russians, who were a bit late in reaching Germany, had to be satisfied with unused V2 rockets left behind by the US Armed Forces. These were then transported to Russia for reverse engineering and recreating the technologies within. So, in a way, all the modern rockets that we see today could be considered to have been evolved from the German V2. When all these things were happening elsewhere in the world, there were a few scientists in India who understood the real potential of this new technology called rocket science. They understood that if developed in the right sense, this technology could be used not just for warfare, but could be used for improving the standard of living of the commonest of the common man of a developing nation like India. In fact, a small team of such scientists under the leadership of Vikram Sarabhai approached the government of India and requested that such a project be initiated. Believe me, in those days in 1950s, for the parliamentarians, it would have been like hearing a story out of a science fiction novel rather than a realistic picture of launching a rocket. Now, the government of India, or the cabinet in fact, requested Sarabhai to prove two things before funding the pilot project. The first one was in fact to prove that the team could launch a rocket from the Indian soil, and the second one was to prove that this technology could be used for the benefit of the commonest of the common man of this nation. Sarabhai, being a visionary himself, understood that the biggest challenge among these two would be to launch a rocket from in the Indian soil, and he approached this problem first. Sarabhai's team was quick in understanding that developing and launching a rocket from Indian soil would be an enormously complex task. They came up with an innovative solution to this technological conundrum. The task given was to prove their capability in launching a rocket from the Indian soil and not to develop one. Sarabhai decided to travel across the globe in an attempt to buy already operational rockets, launching pads, and associated systems from friendly nations. A small experimental sounding rocket called Nike Apache was procured from USA, the sodium vapor payload from Switzerland, and so on. All these were brought to a rather sleepy fishing village off the coast of Thiruvananthapuram and were assembled for the maiden launch of a rocket from the Indian soil. The task was accomplished with the launch of Nike Apache from Tumba on 21st of November 1963. The second task assigned to the team of Vikram Sarabhai before the government of India approved their project for rocketry was in fact to prove that this technology could benefit the commonest of the common man of the nation. Now, this task was achieved in a rather simple but innovative way. A helicopter was hired by the team and cameras were attached beneath the helicopter. Now, this helicopter flew over Thiruvananthapuram and they could capture and predict the spread of a particular disease in the coconut trees at Thiruvananthapuram. In this way, the team could successfully prove that this technology, that is the aerial photography technology, could be used to benefit the commonest of the common farmers of this nation. Now, this innovative way of proving was in fact a novel approach, and with this novel approach, they not only proved the aerial photography's use but also extrapolated its use to the satellite technology, which could cover not just Thiruvananthapuram but the entire India and the Indian subcontinent at large. After completing the two tasks assigned to them successfully, Sarabhai's proposal for setting up a rocket launching station in India and to develop rockets was approved by the government of India. Now, they started with the humble rockets called as sounding rockets. Sounding rockets are nothing but very simple rockets which would just go through the atmosphere to almost like 100 to 200 kilometers and then fall back. As they ascend up in height, the measurement systems or the avionic systems inside the rockets would measure different parameters of the atmosphere and altitude, like the temperature, pressure, humidity, etc., and would transmit them back to Earth. These transmissions would be used as data for generating simulations and for running codes to predict the weather conditions for the next few weeks. Over the years, ISRO has developed a series of sounding rockets under the name Rohini Sounding Rocket Series. Rohini Sounding Rocket Series ranges from RH75 to RH560, where RH represents the Rohini series and the number beneath the RH represents the diameter of the booster stage. Rohini sounding rockets are generally launched on all third Wednesdays from Tumba Equatorial Rocket Launching Stations at Thiruvananthapuram. These rocket launches aids the meteorological scientists to understand and study the different phenomena that is occurring on the atmosphere, especially in the upper atmosphere, ranging from 100 kilometers to 200 kilometers in altitude, where the weather balloons cannot function, neither the satellites can function.
Two, one, zero.
In science, experimentation and failures from experimentation are both considered as important as successes. All science have been developed through experimental analyses and through failures and their analyses. So, the Indian scientists also took up the satellite launch vehicle technology development in a step by step manner starting from experimental launches. After the successful development and flight of Rohini sounding rocket series, they moved on to the experimental satellite launch vehicle project called as the SLV or the Satellite Launch Vehicle 3 project, and then the Augmented Satellite Launch Vehicle program or the ASLV project.
2, 1, 0. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10.
Now, these projects, these were small rockets which were being built and would launch small satellites into smaller orbits. Now, the aim of these rockets or these two rocket projects were only to experiment and to understand this technology while developing the industrial as well as the other scientific capabilities for developing and launching rockets from the Indian soil. Now, these small rockets were bound to fail, and they did fail. And these failures did help us understand much more in-depth know-how of what rocketry is to its core. Now, these launch vehicles or the SLV-3 and ASLV were, as I said, experimental vehicles and were small vehicles. After the successful development and launch of the SLV-3 and ASLV, the two experimental launch vehicles, the ISRO scientists barged into the development of its first commercial satellite launch vehicle, the PSLV. Polar Satellite Launch Vehicle was huge when compared to its predecessors. It was 2.8 meters in diameter and almost 44 meters tall. Now, to give you a glimpse or an essence of how huge PSLV is, we have a small scale model of a human being right here. This model of a man, an average sized human being, in my hand is a scale of 1:10, which means an average man will be 10 times this size. Now, PSLV rocket compared to this man is this model. This model of PSLV is in fact 10 times smaller than the actual PSLV. PSLV, as I said, is huge and is as tall as an average 12-storied building that you can see around your home. PSLV or Polar Satellite Launch Vehicle is in fact the workhorse of ISRO. Developed in the early 1990s, this rocket has been used not only for launching polar satellites, but it has also been used for a multitude of missions, including the prestigious Mars Orbiter mission and the Chandrayaan-1 mission of Indian Space Research Organization. PSLV, with its 6 strap-on configuration, is capable of lifting up to 1.8 tons class payload to the sun-synchronous polar orbit. PSLV is a 4-staged rocket. The first stage of PSLV or PS1 stage stores 139 tons of solid propellant. The second stage carries 40 tons of liquid propellant and uses Vikas engine to power it. The third stage is again a solid stage which carries 7 tons of high energy specialized solid propellant, and the fourth stage runs on 2 engines with liquid propellants. PSLV is one of the most reliable rockets of ISRO. Over the past 3 decades, it has flown more than 50 times with only 2 failures. Moving on from PSLV or the Polar Satellite Launch Vehicle to the Geosynchronous Satellite Launch Vehicle or GSLV was a bigger task. In fact, GSLV is very much big, very much powerful than PSLV. To launch a satellite into a smaller low Earth orbit is one task, but a tremendously huge amount of energy is required to push the satellite to a bigger 36,000 kilometer orbit, which is the geosynchronous or the geostationary orbit. So this task requires a bigger rocket than PSLV, and that rocket was GSLV Mark II, a model of which you can see behind. GSLV Mark II is capable of launching almost 2.8 tons worth payload to a geosynchronous transfer orbit or a GTO when launched from SDSC Shah or Sriharikota. Now, this is again a 1:10 scale model, which means the actual GSLV will be 10 times the size of this model. GSLV is a very powerful rocket. GSLV Mark II consists of 4 strap-on boosters, which are all 40-ton propellant loaded with liquid propellants. Each of these are powered by Vikas engines, which produces almost 620 kilonewtons of thrust. The core booster stage is in fact the S139 stage, or the solid stage with 139 propellant capability, having 5 segments. The second stage, or the GS2 stage, is again a 40-ton propellant loading stage, which is powered by liquid propellants. The third stage is a special stage, which is the cryogenic upper stage, which is the most efficient upper stage ever developed by ISRO. The cryogenic upper stage is powered by a CUS engine, which was previously imported from Russia but then developed completely indigenously by the Indian Space Research Organization. GSLV is capable of lifting 2.8-ton class communication satellites to geostationary transfer orbits when launched from Sriharikota. As mentioned earlier in this video, ISRO scientists have been taking up tasks one after the other in a step-by-step manner. PSLV was developed, GSLV Mark II was already launched, and then came the time for GSLV Mark III. After the successful launches of GSLV Mark II, it was felt that India should have self-sufficiency in launching all her satellites from an Indian soil using an Indian rocket. Along with this task, ISRO was also given a task of developing human spaceflight project, where an Indian citizen would be launched to space and brought back using a launcher developed by India. For all these new tasks, a bigger, a powerful rocket was required, and that rocket is GSLV Mark III. The model that you see here is actually 1:10 scale model of GSLV Mark III, and GSLV Mark III is the most powerful rocket ever designed and developed by ISRO. GSLV Mark III is also being human rated to suit herself for flying a human being aboard. GSLV Mark III is a 3-stage vehicle. The 2 strap-on boosters, the S200s, houses 200 tons of solid propellant and is one of the biggest raw solid boosters ever developed internationally. The core stage is L110 stage, which consists of 2 Vikas engine and houses 110 tons of liquid propellant, which is earth storable propellant. The third stage, or the indigenously developed C25 stage, is a cryogenic upper stage consisting of 1 C20 engine and is powered by liquid oxygen and liquid hydrogen at cryogenic temperatures. GSLV Mark III is one of the most powerful rockets ever built by ISRO, and at present it is undergoing a process called as human rating. A human rated vehicle is a vehicle which is capable or which is safe for carrying humans to outer space. It is this vehicle in the human rated version which will be used for the Gaganyaan project. We sincerely hope that you enjoyed watching the first episode of our video series done in connection with the World Space Week celebrations. We also hope that you would watch the next episodes of these series, which will enlighten you with different aspects of rocketry and spacecraft technology. I am sure that you would have got inspired hearing the story of how a small group of scientists were able to transform India into a space global power. This is Kiran Mohan signing off. Thank you for watching.